Hello friends, this video on number systems part 5 is brought to you by examfear.com. No more fear from exam. Let's understand decimal expressions. You must be knowing what is decimal expressions. You must have used this term something like 1.28, 7.320, something like that, where you have a number, then a dot, and then a number. These kind of numbers are decimal expressions. Let's take three rational numbers. Let's take three rational numbers as 10 by 3, 7 by 8 and 1 by 7. Please note they are not just three random rational numbers. I have taken these numbers for some purpose. They are not random three rational numbers. Now let's divide each of these to get decimal numbers. So let's divide the first one, 10 by 3. So 10 by 3, if you divide, you get 3, 9, 1. 1 you can't divide with 3, you get a point, you get 0 here. And then 3, you get again 9, again you get 10, again you divide, again 9, again 10. So the list continues, right? And there is no final end to this. So 10 by 3 is 3.33 dot 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 dot. The list continues. Okay. Let's divide the second number, 7 by 8. So I have 8 here, I have 7 here. I can't divide, so there's a put 0 point, it becomes 0. And then 8 into 8, 64. Then I have 60 here. Then I have 8 into 7 is 56. 40, 8 into 5, 40, cross. So the value is 0.875. So there is a remainder. The remainder is 0. Here the remainder is 0. But in this case, the remainder is not 0. Right? So here, remainder never becomes 0. Right? And there is a repeating string. So if you see the remainder, there is a repeating sequence of remainder. There is a repeating remainder. Okay. So in first scenario, we saw that the remainder never became 0. There is a repeating sequence. The second scenario, remainder became 0. Third is 1 by 7. So put 7 and 1 here. We can't divide. Put a 0 here. So what you get is 7, 30, 28, again 20, 7 into 14, and then 6, 60, 7 into 8 is 56, and then 40, 7 into 5 is 35, again 50, 7 into 7 is 49, and then 10, and 7 into 7, 10, 1, 7 into 1 is 7, and 3, 4 is 28, and 2, and then 2, 7 into 2 is 14. So the list continues like this. Here also if you see, the remainder is not 0. And is there a repeat? So let's see that 1, 4, 2, 8, 5, 7. And then again, if you see 1, 4, 2, and if you do more calculation here, this becomes 60. And 60 is 7 into 8, that is 56. 40. And for 40 you have to say 7 into 5, 35. So here also if you see this is repeating, right? So this is repeating, this part is repeating. So these all were three rational numbers. So all these three rational numbers, we saw two cases. One case we saw was the remainder becomes 0, and the second case we saw was remainder never becomes 0, but in these both case we saw a repeating remainder. Okay, please note, in both this case there was a repeating remainder. Okay, this is a case 1 where we got terminating decimal, and this is the case where we get, in these two scenarios, non-terminating but repeating. So for any rational number, these are the only two options. Either you will get a terminating decimal or you will get non-terminating repeating decimal. Okay. This was for rational number. All these three numbers which I took was rational numbers. So if you take some irrational number, for example, pi, root 2, root 3. So there you get non-terminating and non-repeating. So it doesn't terminate and non-repeating decimal. Okay. So now for the real numbers, there are three scenarios. Let's recapitulate that. Three cases for a real number. First is if you have a rational number, then you get two scenarios. One is the remainder becomes 0. The second one is remainder never becomes 0 but it repeats. Remainder becomes 0. A good example is, for example, 1.28. Remainder number never becomes 0. For example, 1.2828282828, something like that. Right? And if for a rational number, if you actually divide, you will get a decimal where the remainder never becomes 0 and it is not repeating also. For example, pi, you see it is 3.1. The list continues. It's a long list. If you want, I can write it for you. Pi is actually 3.14159265897993238446, and still the list continues. Root 2 also is an irrational number. The list is a big 1.41421356237309509504889. Like that. The list continues. Okay, so as we've explained that real numbers are the numbers which you can represent on a number line, right? And these numbers can be either rational number which you can express in P by Q form, or irrational number which you can't express in P by Q form. That is something we know. Now, if you talk about the decimal representations of real numbers, so we classify decimal representation separately for rational and irrational because the representation is different. For rational number, we get two scenarios. One is the remainder becomes 0 and the second is the remainder never becomes 0, but there is a repetition. For irrational number, the remainder never becomes 0 and there is no repetition as well. See, there is no repetition in this. Okay. Please note, pi, when you say pi is 22 by 7, a lot of people ask me, that is wrong. It is, pi is not equal to 22 by 7, it is close to 22 by 7 because 22 by 7 is a rational number. And pi is, we know that it's a irrational. So when you say pi is 22 by 7 or 3.14, it is wrong, right? Because pi is not equal to 22 by 7 or 3.14. Just for ease of calculation, we assume pi to be approximately 3.14, but the value is this way. Okay, thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.